In today's lecture, we will learn some theorems about group theory. Our first theorem is about uniqueness of identity. That is, the identity element is unique in a group. So proof: let G dot be a group. If possible, suppose that there are two identity elements in G. Say E and E dash or E prime. Since E is the identity, so for A belongs to G, A dot E is E dot A. For A equal to E dash, we may write E dash operation E is A operation E dash. This is 1. Since E dash is the identity in G, so that for A belongs to G, A operation E dash gives you A, E dash operation E. Now again take A equal to E, we get E operation E dash E dash operation E. From 1 and 2, now from 1 and 2, you can see that E dash operation E is E dash, and again E dash operation E is E. That is, E dash operation E is equal to E dash, and this is equal to E dash operation E, and which is equal to E. So finally what we get? E dash equal to E. Hence identity is unique in G. So this completes the proof of first theorem. Second theorem is cancellation law. A group G hold cancellation laws. A group G holds cancellation laws, that is, for any three elements A, B, C belongs to G, we have AB equal AC implies B equal to C. This is called left cancellation law. And second, BA equal to CA implies B equal to C, and it is called right cancellation law. Let us prove. Let G dot be a group and let A, B, C belongs to G. Arbitrarily. That means A, B, C are arbitrary element of group G. Then AB equal AC, because since A belongs to G implies A inverse belongs to G. So applying both sides by A inverse, that is, A inverse operated on both sides of this inequality AB equal to AC. Now applying associative law, that means grouping is changed using associative law. Since A inverse A is the identity element E, so EB is equal to EC, equal to E, where E is the identity element. For this you may add here let E be the identity element in G. So now the property of identity element EB gives you B and EC gives you C. Now using EB is equal to B and EC is equal to C, using this property. So AB equal AC implies B equal to C. This proves the first result. Next, In a similar pattern, we have to show BA equal to CA. So BA equal to CA. For this, operate this identity on both sides by A inverse. Now again change the group, that is use associative law for associative property. Write down here which law you are using. Then A inverse gives you the identity element, and B operated with the identity element gives B, and here C again. Now state the property here using the identity property here. We obtain B equal to C, that is BA equal to CA implies, you may write down here the sign of the implication, implies B equal to C. This proves second part. So hence this completes the theorem that cancellation law hold in a group